Good morning, dear student. In today's lecture, we are very much interested in the second section of CHG 290, that is our practical course, in which we selected the elective option A, that is electrochemical method of analysis. In this electrochemical method of analysis, we study the conductometry, potentiometry, and pHmetry experiment. So, in today's lecture, we are very much interested in the part first, that is conductometry experiment. So, we are very much familiar with this instrument, and the practical first is the hydrolysis of ethyl acetate using NaOH. It is hydrolysis of ethyl acetate by NaOH using conductivity measurements. So let us discuss. So we are very much familiar. So already we performed this experiment in SY BSc, that is acid catalyzed ester hydrolysis and base catalyzed ester hydrolysis. The acid catalyzed ester hydrolysis, it is your first order reaction, but the base catalyzed, that is with the help of NaOH. So base catalyzed hydrolysis reaction of this ethyl acetate is your second order reaction. So with the help of conductometry, measuring the conductance of solution, we can easily find out the rate constant for this second order reaction, that is hydrolysis of ethyl acetate by NaOH using hydrolysis of ethyl acetate by NaOH. So let's discuss some theoretical parts regarding to this hydrolysis of ethyl acetate. So if you consider the reaction, that is CH3 COO C2H5 CH3 COO C2H5, it will react with NaOH and there is a formation of CH3CO minus Na positive sodium salt of acetic acid, plus we get C2H5OH, that is your ethanol. And this reaction is called saponification of ester. This reaction is called saponification of ester. It's called saponification of ester. If you consider this reaction, the velocity constant or the rate of this reaction, it is directly proportional. So whatever the rate of this reaction, it is directly proportional to the concentration of ester, that is methyl acetate, and concentration of base, that is NaOH, and therefore it is your second order reaction. So let us discuss the practical parameters regarding to these reactions. So we are very much familiar to this reaction. It is your second order reaction, but with the help of conductometry we can easily find out. So we are very much interested by measuring the rate constant of this second order reaction with the help of conductometry. So let us discuss the requirements. So we require the chemicals for this experiment. Which chemicals we required? That is, we required 0.2 molar methyl acetate, 0.2 molar ethyl or methyl acetate. So you can use anyone. 0.2 molar ethyl acetate. Then we required 0.05 molar NaOH, 0.05 molar NaOH. And then we required 0.01 molar sodium acetate, 0.01 molar sodium acetate, and the conductivity water for this experiment. So we required ethyl acetate, then 0.05 molar NaOH, and then we required 0.01 molar sodium acetate and conductivity water. So let us discuss the procedure for this experiment. So first you have to standardize or calibrate the conductivity instrument by the instruction given. Standardize the conductometer by the instruction given in manual. So first point is to calibrate, or we can see first to standardize the conductometer, and then clean the conductivity cell. Second point, clean the conductivity cell and fill it with 0.01 molar then fill with 0.01 molar. So in this case it is 0.01 molar, so they have the mistake in practical book. So they select 0.01 molar NaOH and 0.01 molar sodium acetate. It is not 0.05. So 0. And fill with 0.01 molar NaOH solution and measure the conductance of that solution measure the conductance of this NaOH solution and call it as C0. So whatever the conductance of this 0.01 molar NaOH solution is considered as C0. Similarly, let us discuss the next point, that is the third point. So again, wash the conductivity cell and fill with 0.01 molar sodium acetate solution and measure the conductivity call it as C infinity. So whatever the conductivity of NaOH solution, it is considered as C0, and whatever the conductivity of this sodium acetate, it is considered as C infinity. Then the next point is that take two stopper bottle. So to take two stopper bottle, in bottle first we take 50 ml of this 0.05 molar NaOH solution plus 125 ml water, and in bottle second you have to take 12.5 ml of 0.2 molar ethyl acetate. So you have to prepare two bottles. So in one bottle you have to take 50 ml 0.05 molar NaOH solution and 125 ml water, and in bottle second you have to take 12.5 ml 0.2 molar ethyl acetate solution plus 62.5 ml of water. Keep the bottle in thermostat to attain the desired temperature. So You have to prepare this bottle and keep in thermostat to attain that is high temperature. And then finally, the next point is that finally mix the solution and start the stopwatch. So mix the solution and start the stopwatch. Mix the solution and start the stopwatch. Call the time of mixing. Call the time of mixing as t is equal to 0. So when you mix these two bottles, then consider the time it is t0. Then fill the conductivity cell with reaction mixture and stir it continuously. So after mixing, call the time of mixing as t is equal to 0 time, and fill the conductivity cell with the reaction mixture. We put out the reaction mixture and fill the conductivity cell with this reaction mixture and stir continuously with the help of magnetic stirrer, and record the conductance value as Ct at the interval of 5, 10, 15, 20 and 40 minutes. So after mixing, you have to pipette out the reaction mixture and measure the conductance by every 5 minutes up to half an hour. So you have to measure the conductance. So you don't take any aliquot of another mixed solution. So you have to take only one, or you have to take once the aliquot of the reaction mixture and measure the conductance with the help of conductometer within half an hour. So let us discuss some observation or observation table. So what is there in observation and measure the conductance? So let's discuss the observation. So we already discussed, that is observation, that is C0. So what is our C0? That is conductance of reaction mixture. Conductance of reaction mixture at t is equal to 0. At t is equal to 0, which is equivalent to the conductance of 0.01 molar in NaOH solution. NaOH solution. C0, the conductance of reaction mixture at t is equal to 0, which is equal to, or which is corresponds to the conductance of 0.01 molar NaOH solution. So whatever the conductance here, right here. And again the C infinity, again the C infinity, which is equal to the conductance of reaction mixture. Conductance of reaction mixture at t is equal to infinity, so which is corresponds to the conductance of 0.01 molar sodium acetate solution. So whatever the conductance of the reaction mixture at t is equal to 0 is nothing but the conductance of 0.01 molar NaOH solution. And second, whatever the conductance of the reaction mixture at t is equal to infinity is nothing but the conductance of 0.01 molar sodium acetate solution. So let's discuss the observation table. So what you find out, let's discuss. In observation table, so if you consider the observation table for this experiment, this observation table contain time in minutes. So after every 5, 10, 50, 20 and 25 minutes, you have to find out the conductance. You have to measure the conductance. Then you have to find out the X. So what is this X? that is your nothing but the x is nothing but your C0 minus Ct. So C0, so we are very much familiar, we know what is C0. C0 is the conductance of 0.01 molar NaOH solution, and Ct conductance at different times. For example, the conductance at time 5, when time is 5 minutes, then time is 10 minutes. So Ct, the conductance with respect to different times. So then you have to find out this, that is x, which is equal to C0 minus Ct. So whatever the conductance of the reaction mixture at 0 time minus the conductance of that solution at given time. So you have to find out the difference, that is C0 minus Ct, and Ct is nothing but your conductance of reaction mixture at different time. Then you have to find out this A minus x, that is your Ct minus C infinity. So Ct minus C infinity. X is your reacted concentration, A minus x is your remaining concentration. Then you have to find out this value, that is C0 minus Ct upon Ct minus C infinity. Ct minus C infinity. And then finally you have to find out the rate constant, that is K, which is equal to 1 upon A into T, 1 upon A into T into x upon A minus x. So just find out this value, that is conductance. You have to observe the conductance of reaction mixture at every 5 minutes. Then you have to find out the reacted concentration, remaining concentration, and then finally you have to find out the rate constant, because it is second order reaction. So K is equal to 1 upon A by T, x upon A minus x, and then the calculation part is there. Then the calculation part is there. So by calculation we can find out, and similarly by graph we can also find out the rate constant. So calculation, then if you consider, that is we find out the K by calculation, that is K is equal to 1 upon ATX upon A minus x. Similarly by graphically we can find out the rate constant, that is graph. So you have to plot the graph of C0 minus Ct upon Ct minus C infinity versus time, and then you have to find out the slope and rate constant. After that you have to find out the rate constant. So when you plot the graph, we get such a kind of graph, a straight line graph, C0 minus Ct upon Ct minus C infinity versus time. So we get a straight line graph with slope which is equal to ak. So if you plot the graph of C0 minus Ct upon Ct minus C infinity against T, then we get slope which is equal to ak. And if you know the slope, and then we can easily find out the K value, that is slope is equal to A, slope is equal to ak. So the value of A is given, that is 0.01 and into K, and the slope is also there, and we can easily find out the K. Okay, we can easily find out the K. So by calculation as well as by graph we can easily find out the K value, that is rate constant value for this hydrolysis of ethyl acetate using NaOH. So keep in mind it is a second order reaction. So the calculation part is given. By calculation and by graph we can easily find out the value of K, that is the rate constant, and finally you have to write the result, that is K by calculation and K by graph, and the unit, it is the unit of this second order rate constant is liter per mole per minute. So this is all about the hydrolysis of ethyl acetate, uh, hydrolysis of ethyl acetate by NaOH using conductometry. So by volumetry we already performed this experiment in SYBSE. By with the help of conductometry we perform this experiment in MSc first. In the next lecture we will discuss the another practical of this conductometry. Thank you.